Today I am going to explain you how to find the valence electrons at least for 6 elements. So according to the Niels Bohr's theory, Niels Bohr proposed the electrons revolve in a fixed orbit. So this is the diagram. So for every element there is a nucleus. In the nucleus protons and neutrons will be there. Around the nucleus electrons will be revolving around the nucleus. So he introduced the concept of energy levels, and they are called as quantized orbits, and he assigned the orbit number as 1, 2, 3, 4 like that. So and the energy levels were labeled as K, L, M, N. So the Bohr also stated that each cell should have the maximum electron capacity. It is given by the formula 2n square. This formula is very important in order to find the number of electrons in each orbit. The orbit is also called as a cell. Here I have given the table, element name, atomic number and number of electrons placed. For example, the first element boron, it is represented by B, and the atomic number for boron is 5, and according to the formula 2n square, when n is equal to 1, 2 into 1 square is 2. The number of electrons in the first orbit is 2. First you draw the nucleus, after that you draw the first orbit, you mark 2 electrons, and when n becomes 2, second orbit, 2 into 2 square, that is 8. Total this is 8, but the number of electrons, total electrons are 5. According to the Bohr's formula, we should have 8 electrons in the second orbit, because 2 into 2 square is 8. But what is the total atomic number of boron? 5. But among 5, 2 are already placed in the first orbit. How many are left? 5 minus 2 is 3. So you should mark 3 electrons in the second orbit. This is about the boron. The second example is silicon. The atomic number for silicon is 14. And for the first orbit, when n is equal to 1, 2 into 1 square is 2. You mark 2 electrons in the first orbit. First you mark the nucleus, protons and neutrons in it, and in the first orbit you mark 2 electrons. And in the second orbit, when n becomes 2, 2 into 2 square is 8. In the second orbit you mark 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons in the second orbit. So what is the total atomic number? 14. Among 14, 10 already placed. 2 in the first orbit, 8 in the second orbit. Totally how many placed? 10. 14 minus 10 is how much? 4. So 4 is left in the third orbit. Actually how many should be there in the third orbit? 2 into 3 square. 9 into 18 should be there, but I left with only 4. So you just mark 4 electrons in the outermost orbit. This is about silicon. Next is germanium. The atomic number of germanium is 32. According to the Bohr formula, 2n square is 2. So the number of electrons in the first orbit is 2. It is marked as 2. In the second orbit, 2 into 2 square is 8. 8 electrons are placed in the second orbit. In the third orbit, 2 into 3 square, 18 electrons are placed in the third orbit. And according to the Bohr's formula, the fourth orbit, 2 into 4 square, how much? 32 should be there, but only 32 is the atomic number. Among this, 18 plus 2, 10, 20, 28 are filled. How many left? 32 minus 28 is 4. So you mark 4 electrons in the outermost orbit. Similarly, arsenic. The atomic number for arsenic is 33. So according to the Bohr's formula, first orbit has 2 electrons. 2 I marked. Second orbit will get 8 electrons. 8 electrons in the second orbit. Third orbit, 18 electrons. 18 are marked. So how many over 18 plus 8? 18 plus 2? 20. 28. 33 minus 28 is how much? 5. So 5 electrons are left in the last orbit. 1, 2, 3, 4, 5. Similarly, phosphorus. Phosphorus has got 15 atomic number. So in the first orbit, 2 electrons. In the second orbit, 8 electrons. 8 plus 2 is how much? 10. 15 minus 10 is 5. So 5 electrons are left in the outermost orbit. So these two are called as pentavalent elements because there are 5 electrons in the outermost orbit. Then the last one is carbon. The carbon has got atomic number 6. So according to the formula, 2n square is 2. 2 electrons are placed in the first orbit. How much left? 6 minus 2 is 4. So the 4 electrons in the last orbit. In this way, you can find out the valence electrons for the at least 6 given elements is given in the syllabus. So what is valence electrons? The electrons present in the outermost orbit are called as valence electrons. In this way, using this formula, you can find out the number of valence electrons in different elements.